So I'm very happy to be back in Kuala Lumpur, Malaysia. I just wanted to give you a little short introduction. So I'm using the world map because I like to collect flags of different countries I have been. So as you can tell from my accent, I'm from Germany originally, but I grew up in West Africa and Liberia. And you can see the flag looks quite similar to the Malaysian one. I did my master degree in computer science in Portland, Oregon, long time ago. And then I lived most of the time in Europe and Switzerland. That's a very beautiful country. If you ever have the chance to come to Europe, stop by in Switzerland. It's expensive, but worth a couple of days visit. So this is also where I worked at an engineering company. So my background is I started as a software developer, Java. That was before all the web application stuff. So that was Java database. Became software architect, designing software systems, mainly using UML and other models. So I'm a fan of models. I also worked as a project manager, but then I came in a larger project, actually by chance. I came into requirements engineering. So this was quite a challenging project. I spent 4 years in that project. The customer was an industry company building steam turbines for power plants. I don't know if you have ever seen pictures of these steam turbines. They're huge. They fill whole rooms with these rotors like an airplane engine, just like the size of a little hall. And they had to replace the old software system they had written in Fortran. So since it's just a replacement, management thought we don't need requirements engineering. I mean, everything is clear. Just look what the old tool does and program it in a new. I mean, you might know these situations. So after a year, they called us to set up a requirements engineering process. So I first was developer, and since they didn't have enough requirements engineers, I said, okay, why not? I'm interested. I did the IRAP CPRE foundation level certificate to know more about it, and became requirements engineer, and after 2 years then requirements manager, responsible for the whole team of 7 requirements engineers in the project there. I have also worked as Scrum Master or Scrum Product Owner. I mean, Product Owner is related to requirements engineering. That's one of the tasks. Yeah, and I used to live in Indonesia for a couple of years and came very frequently to Malaysia. That's doing CPRE trainings. So I'm very happy to be back here now. Thank you for inviting me. And right now, currently, I live in the US, so something brought me back to the US. My wife got a job there, so I'll move along. Yeah, so my main background is requirements engineering, and that's why I would like to kind of highlight that aspect a little bit. So I'm not a tester from background. So the title, Deriving Intelligence from RE for Better Testing. So before we dive into that, let's first have a look at, give you a little overview of requirements engineering. I don't know, is anyone here working as a business analyst, requirements engineer, analyst, however you call that role? Don't see any arms, so everyone tester? There's one, okay. Yeah, then, so if we talk about requirements engineering, I think in the English-speaking country, Anglo-American countries, it's mainly called business analysis. So what's the difference between business analysis or business analyst and requirements engineering is that requirements engineering is more close to the system. So if it's about business process analysis, that would not be considered requirements engineering, but would be considered business analysis too. So a business analyst in a way is doing everything a requirements engineer is doing, plus the level of the business processes. Yeah, requirements engineering can be described, or all the tasks, all the activity you do can be described in 4 major activities. So one is elicitation, where you gather the requirements. The second is the documentation, where you have to kind of write down the requirements depending on the process in different formats. And then very important to validate and negotiate requirements. And then typically there is something like a 4th activity where all these things are part of, where it's about managing the requirements process. Yeah, let's have a look a little bit in what's going on there. So the elicitation activity, part of it is also managing the stakeholders. So this is the most important source of requirements, the stakeholders. So you have to first kind of find out who they are. If somebody did not create yet a stakeholder list, it's also the task of a requirements engineer to do that. But it's not only just creating a list, it's also keeping up the communication, having a good relationship with these people, and also try not to miss somebody who later at the end of the project shows up and asks for more requirements. That would not be good. So if you know your stakeholders, you can start engaging them, and typically what you do in a new project would be a system context analysis. So system context analysis is kind of the high-level view on your system that you're planning to implement. So here it's about to find out who are the different users, who are the external systems that interface with my system. So everything in the context around my system that influences requirements onto my system. And the requirements engineer will use a variety of different elicitation techniques, they're called. I guess everyone knows what an interview is. So interview you can use to question stakeholders, get requirements. You can use questionnaires to send to a great number of stakeholders. Or you can use observation techniques, field observation or other techniques to try to find out what they are doing. And if it's about more innovative aspects of the system, you can then do creativity techniques like brainstorming and other techniques to find requirements that stakeholders are not really aware that this is something they actually could need. So in the project I have been, we had to use a wide variety of these techniques. So we were doing a lot of interviews. The problem was that the stakeholders were not co-located, so they were not all in the same company. They were actually in different countries, speaking different languages. So that makes requirements more interesting. So we had to sometimes just do things via Skype or just sending questionnaires to stakeholders. Also the number of stakeholders in that project was around 400. So that's quite a lot of people you have to kind of engage and try to get the requirements from them. So elicitation of the requirements is one part, but then you have to kind of boil what you learn from that down into some format, into some structure that you can document, because otherwise it's just in your head, and that's not very useful because you're not the person who will develop the system. So the development team needs the instructions, needs the specification, and that depends highly on the process you're using. So if you would be in a waterfall, you might have a nice, big, thick specification document with everything in it. Requirements could be in natural language, where you just say statements. You could use requirements templates. These are kind of structures that help you to formulate requirements in a good way. Or you could use models. So, as I said, I'm a fan of modeling. So I always do class diagrams for my data models, but it depends on the process. So if you're using Agile or other processes, the documentation might look different, but there will be a major activity documentation. If you just do elicitation and documentation and then hand over the specification to the development team, that's not a good idea. So here you need, in a way, testing of the requirements. The first time you do that is the validation. So this is an important part to really check that in the communication with the stakeholders. So while you talk to them, when you documented the things, there are many mistakes you can make. It's human communication. So human communication always has a lot of interpretation to it. So you think you completely understood the stakeholder, what they wanted to tell you. You write it down, you sit together with them, and you learn actually that you completely misunderstood them. Or you were missing something. So this is a very important aspect of requirements engineering, is the validation. Unfortunately, often this is a little bit neglected or done too late. And if you look at these three activities, they look a little bit like their processes, the way I'm drawing, I was drawing them here with these long arrows. But what they actually are, they're parallel activities. So you might start out doing some elicitation, interviewing somebody concerning security aspects of the system. 2 days later, you have another workshop planned with stakeholders about some features for the marketing of the web shop that you're planning. And in parallel, you can start documenting what you learned from that first interview. So then you do the workshop, you document the workshop, and then you're ready to validate while you continue doing elicitation. So these are parallel streams that you always do, depending on kind of the topic, the availability of stakeholders. So this is not kind of first do all the elicitation, then do all documentation, then all validation. That's not like that. And the last part, the requirements management. Yeah, this is kind of not really an activity. I mean, this involves all different aspects about, so how do I organize, how do I manage all my requirements? You can still use an Excel sheet if it's 100 requirements. In our steam turbine project, we had, I don't remember the exact number, I think it was like 2,000 requirements. I mean, that's very hard to keep an overview over that. So we had a special requirements management system, a horrible database-based system. Nobody liked to use that. So this is one aspect, or how do you adding attributes to requirements to make them searchable, that you can quickly figure out, okay, I want to see my quality requirements, or I want to see all my quality requirements security aspect. Prioritization is a topic. I mean, you need to, together with the stakeholders, prioritize the requirements. The development team needs to know what's more important than something else. Ideally, you define an order, in which order it should be implemented. Traceability, you often hear. So traceability means that you can link different information and you can trace back to the source. For example, if I have a requirement and somebody asks me, where did you get this from? If I say, oh man, that's like a month ago, I have no idea who told me that. That's not good. So I just look up in the system, check the column source, and it will tell me the name of the stakeholder or the document I was analyzing. So this is all about traceability, and traceability can also be forward, tracing requirements to test cases, and so on. And then versioning, change management, and yeah, always the topic tools is also in every project. Which tool do I use for managing my requirements? I guess depends how much money you want to spend for that. So as I mentioned before, mainly the documentation part, but maybe also other aspects of how you organize your work depends on the process you are in. So I just wanted to kind of visualize that very quickly here. So in this traditional structured waterfall process, there might be a vision created in the beginning, and based on that there is an analysis phase, that means the requirements engineering phase. And the deliverables of that would be the requirement specification, containing 100% of the requirements in it, maybe a glossary to define business terms, and that gets handed over to a design team who then create a design, they hand it over to development team, they implement the system, then you would be called and they tell you, okay, here's the system, please test. And when the system is then released and up and running, there is a maintenance phase where they keep the system up to date. So this would be clear structure, everything about requirements is in the beginning. After the analysis is done, the requirements engineering team moves to another project and the design team continues to work. So this doesn't really work so well in some kind of project, especially if there's a lot of changes. So what happens here? If this is a larger project, so now you're implementing, testing, that's a year after you have done the analysis phase. In a year, a lot of things can change. So then you have to have complicated change management processes to adjust or adapt. Maybe you can't, you first have to finish. So this doesn't work well in environments where you need to quickly have something, you want to be agile to changes. So that's where in a way Agile came up. One misconception about Agile that people often had, I have seen companies who started doing Agile, so they said, let's do the next project Agile. Okay, on Monday the team is ready, on Monday we start sprint 1. And then they start sprint 1 and the development team asks, so but what do we do? I mean, where are the requirements? And then we say, yeah, we are Agile, so we do them while we go. So, of course, that's not how it works. The definition, in, for example, in Scrum is clear. Before you start your sprint 1, you have a prioritized product backlog with the first set of items for the first sprints detailed out enough to work. So there needs to be, in a way, also in kind of an analysis phase before you can really start your development sprints. Sometimes they call it sprint 0. I mean, there are different names for that. So in that phase, you have not only analysis, so it's not only requirements engineer doing the requirements engineering. And important is you don't do 100% of your requirements here. You do around 60% maybe. So it's first high level, and then you kind of try to look the high risk things and the things that you want to start first. So in that first phase, so everything here in orange is the analysis. You do in a way parallel also to the analysis. You might have already a system architect, a development team. They start already experimenting with possible architectures. And out of that, there will be a vision document, a first set of the product backlog, prioritized by the order of implementation, and maybe also a glossary, depending how complicated the domain is. And then in a way the development sprints start. So then you have the first sprint and second sprint and so on. So what happens here is that the requirements engineering is always kind of in parallel to the development team. So it's kind of an ongoing sprint by sprint, ongoing requirements engineering process. And you do two things. You clarify anything that needs to be done for the current development in the current sprint, or you work ahead for the next sprint. So you go in the backlog, you check, okay, what is planned next sprint? Okay, let me check if everything is clear. Do we have all the requirements? Is everything clearly defined? So that the team can then plan and go with that in the next sprint. So it's kind of, you're all sitting in a train, and the requirements engineering team sits in the first wagon. Doing the stuff, and then the development team comes and also testing. And then you might have, oh okay, now we have the problem with the monitor again, yeah. And then we have maybe it's different releases. Typically, if it's a product development in a company, so you are employed in a company, in the development department, you work on the product of the company, maybe a web application, web shop, whatever, then ideally, the Scrum team that works on the product, or many Scrum teams, will stay for the whole life cycle of that product. It's not project-based, it's Scrum works well if it's also if it's product-based. But sometimes you might have that contractor-client relationship where you implement the software for a client, then you might have all of that, but then you hand it over to the client and they might do something completely different with the maintenance, doesn't even have to be agile. So, but then this is not your team anymore. And we also heard about continuous development already. So this is in a way, okay, now I have to look here. So here you don't have sprints anymore. It's an ongoing development and an ongoing analysis, an ongoing requirements phase. So how this is triggered is also by some kind of a backlog or incoming backlog for features or user stories or whatever you use. And any time something new comes in, the requirements engineer would analyze that, clarify the requirements, document that in the way that the team works in that setup, and then put it in the next column of maybe the Kanban board where it says ready to be implemented. And then the development team would take it out, would start implementing it. The moment this feature is implemented, it gets tested, and the next feature gets developed. So it's a continuous machine running. And as we have heard also in the other talks, of course, this requires a high automation. So testing and everything here needs to be highly automated in order to have that quick output compared to a Scrum where you have maybe 2 weeks or maybe even 3 weeks, 4 weeks of sprints. I just want to bring that in because this can also happen sometimes in projects. Maybe they're user-centered driven. Maybe it's a combination between working Agile Scrum but also user-centered. So what is a user-centered approach is where I develop a product or a system that is highly user-focused. So I want to involve users from the very first day on in my development process. So I'm doing a lot of user research, and out of that user research I learn that I might have different user groups. So let's say if we build our web shop, there might be different kinds of shoppers. So I might have these people who are more impulsive shoppers, so they just kind of log on in the evening if they're bored, and if I suggest something that they like, they just buy it. And then you have another group of shoppers that are these carefully researchers. I don't know if you are somebody like that. You read reviews online, you try to compare prices, try to reading all the reviews on Amazon before you start buying something. So this could be somebody else. So these are different groups, and these groups you can then you can use personas. That's kind of you make such a group. You make an archetypical person for that group to visualize that group. And based on that, you then work with these users to derive user requirements, and this could be then documented as user stories, or maybe you write down scenarios, and scenarios could be visualized in storyboards. So a storyboard, as you see here, I don't know if you have ever seen how like Disney works, if they make the cartoon movies. They have these storyboards where they first sketch the movie scene by scene to get an idea what's going on. So it's showing the story, but it's not really nicely drawn. It's really just sketches to get an idea, and then they improve on that. So this is a technique that is actually used in user-centered approaches a lot to visualize scenarios and then talk to users about that. After that, I take all of that input, design the UI, UX, the user experience, maybe using wireframes, UI prototypes, and then implement the system. And then this keeps going on. So I keep users involved, I add new features. So we will talk also tomorrow afternoon, if somebody is in the usability testing workshop, we will do something like that there. So now this just should give you a little bit an idea, requirements engineering, what is it? What is the output of requirements engineering? And so you see that depending on the process, it can look quite different, and we will talk a little bit more about that in a second. So if you look at the title, Deriving Intelligence from RE for Better Testing, what do we actually mean by intelligence? I mean, you can say, I'm intelligent, but what is the intelligence? So let's look at the dictionary. Dictionary tells us here, okay, one meaning is, of course, the ability to acquire and apply knowledge and skills. Synonym, intellectual, mental, and so on. It's, as you see here, it's about understanding, comprehension, or it can mean the collection of information, mainly of military or political value, or maybe business value. You can say business intelligence. So it has to do about collection of information, information gathering, or you can actually mean the information itself. So it could. And again, here it says military or political information. So it could mean the information, and here they give the synonym knowledge. Information, synonym knowledge. So you see there are different there are two things here that we see. There is, if we look at intelligence, there's information. And information has to do with gathering information or understanding the information. And on the other hand, we have that word knowledge, where it's about acquiring and applying knowledge. So these are kind of the aspects if we talk about intelligence. So information and knowledge, are these the same? Are they really synonyms? Often they're used like that. People talk about, I don't know, the time is over now, but there used to be a time when knowledge management systems were the thing. Everyone was talking about knowledge management system solves all the problems. Actually, what they were talking is information management system, not knowledge management system, as you will see, because, so in my view, it's very important to keep these two things separated. So if you understand that information and knowledge are two different things, then you can also sometimes approach certain things in a project differently, and we will see how that plays into deriving intelligence from RE for testing. So information and knowledge. So what is information? Information is about details, facts, data, statistics, documentation. You find it in books, articles, documents, in Wikipedia, a requirement specification, that's information, product backlogs, SharePoint, where all your product stuff is dumped in. So all of that is information. It's that. Information by itself is useless in a way. So you can write it in a document, keep it there, that's it. But important is actually what we want to get to is knowledge. So knowledge can never be in books. Knowledge is always in the head of a person. That's the important distinction. So knowledge is about comprehension, understanding, being proficient in something, having expertise, so you can do, you can act, recognizing something, it has to do with awareness. And knowledge has to be acquired through experience or education. So this is the important distinction. So if the manager says, yeah, Matthias, before you leave the project, don't forget to document your knowledge. Yeah, that's what they always say. So what do? I write like a couple of pages, document somewhere and say, yeah, I put it on the SharePoint with the label Matthias Knowledge. But of course that's useless. So the question is, how do you come from information to knowledge? Of course, you have to learn, you have to study. So you have to acquire it through learning and practice. There is no quick way to knowledge. It takes time, you need some information to it, you need to experiment with that information that you have, to create that, learn that, and create these mental models that also Paul on the first day was talking about, to create that in your head, until you get the feeling that you understand something. You might not understand everything, actually. You might realize what you understand when you apply it. So it's also a cycle, it never ends. So it's about gathering information, like we said, reading, studying, learning, understanding, applying. So this all plays in. So it would be very nice if I can just take the requirement specification, put it on my head, and wait a couple of hours, and all the information trickles into my head and becomes knowledge. That would be great. Doesn't work like that, so you have to invest time and effort to first kind of gather the information. Depending on the process or how you work, it might not be quite clear maybe what information do you actually get from requirements engineering. Sit down, study, invest some time. Maybe you do that alone, which is sometimes a little tough depending on what you're reading, what you're studying. Or you can do that together, that's more fun. Maybe have a nice little workshop, try to learn together all the information. So it's a process where you have to kind of take the information, gather what you have, and then study, learn, read, experiment, play with it, discuss with others in order to learn that, apply it, and increase your knowledge based on that information that you got. So if we talk about deriving intelligence from RE, so what did we learn now? So intelligence is not just information, it's about knowledge. So first we have to gather the information from requirements engineering. What is it that we are interested in? So the relevant information, and then acquire knowledge from that information through a process of learning. And our goal here is, of course, to improve the testing to better test. So first identify sources of information. I mean, this depends highly on how you work in the project, in your company, what software process you're using. So it could be that you might be able to talk to client customer representatives about anything, any information that could be important, or it's just a project manager that you ask, okay, now here we are the testers, our test team is here now in the waterfall process, where are all the necessary information that we need? Or maybe there are requirements management tools that you can access, so you can ask for access to that in order to be able to see all the requirements and search on that. Project intranets, wiki pages of the project, or maybe it's just shared folders or drives of the project. So this is how we had like kind of a subversion repository. Instead of using it for the source code, we were dumping all documents in there. So you could quickly go to the folder requirements engineering and everything would be in there. So if you know where to get your stuff, if we talk about information from requirements engineering, what do we mean by that? So let's have a look, what do we get from requirements engineering? And I was showing you in the beginning, there are different artifacts that come out of requirements engineering depending on what kind of process you're using. So if you have some kind of a vision document, that would be something which is kind of a product system management summary, you can say. It would show the different benefits of the system or the product. Why do we want to do that? What's the goal? Maybe even goals by different stakeholders or users. What are some high-level features that we are looking for? Maybe there's already a system context described in there. And what are the risks for the project, for example? I'm a fan of glossaries if they're done right. So glossary would give you a list of all the business domain-specific terms, all these technical terms in a project. In our steam turbine project, we had a really big glossary. I mean, you can imagine steam turbine engineering. If you look at these turbines, every part has a name. And the first time they were showing me one of these CAD drawings, I didn't even know what I'm looking at. They had to tell me how, kind of three-dimensional, how this actually looks like. And then you have all these names when they come. And Matthias, did you analyze the shaft blade contour, recursive analysis tool, blah blah blah. And then I quickly can look up in the glossary and learn what do they actually talk about. So a glossary is very helpful in requirements engineering itself if you talk to stakeholders to use the correct terms. But it's also very important, then we see later, for example, for development teams. So if they design a UI, that they use the terms that the stakeholders actually use in the UI and not something that they think it should be labeled. Important is if there's a glossary, it needs to be kept up to date. So a glossary is always a living document. It's not something you do in the first week and then you never touch it. So this can be something that is used, vision glossary could be used in both different kinds of processes, waterfall, agile. If we look more at waterfall, here it's more about documents, requirement specification. So what is in the requirement specification? Again, depends on what kind of process you're using for that structured process, but typically it's suggested that you have some system context view on that. As I mentioned before, it's a high-level view of the system. So you have your actors, your users, groups, you have external systems that interact with the system. And if you know UML, this could be, for example, visualized by a UML use case diagram. That would be a diagram to visualize the context. Quality requirements, that's a very important part. Often gets neglected in projects, also in the requirements engineering phase. Everyone is doing functional requirements, and then at the end we have a week left to, oh, there was something, let's quickly look at security. So the quality requirements is actually something that in the requirements engineering you should do from the first day on. I mean, these are very important because they highly influence the system architecture. If they change, I mean, you cannot just quickly go in and change the architecture if the system is 50% built already. We had that problem in that steam turbine project that they were, since they didn't really have requirements engineering in the beginning, so the development team already started implementing a lot of features. They used Java as a programming language, and there was a calculation engine that could calculate the thermodynamics, steam pass, so it's about thermodynamics, mechanical integrity, things like that. So physical calculations they were doing, and they used some kind of a solver engine developed in Java. When they showed that to the stakeholders, they were really proud. And then the stakeholders said, but this took 5 seconds. The old tool is 1 second. I need 1 second. Okay, that's bad. Né? Quality requirement performance was not really analyzed in the beginning as it should have. So they put a lot of work in it, and they couldn't get it into 1 second in Java, so they had to re-implement this whole solver engine in C. I mean, that's a lot of wasted money just because you didn't do the quality requirements right in the beginning. And other categories of quality requirements are, of course, security is an important one, especially now. I mean, these days, nearly everything is a web application or has a mobile interface. So security becomes more and more important. Reliability of the system, usability aspects. So does my system fulfill usability? Is it learnable? Everything related to maintainability. So if I'm doing requirements engineering and stakeholders already tell me things that are important for the maintenance of the system, I also put them as quality requirements. Because then the architect or the development team sees that already and can plan the system in a way that this can be done easier later on. So things that need to change. So for example, in Switzerland we had an insurance system we were working on, and every 2 years the law changes, and the law has an influence on how the insurance fees are calculated. So we know that every 2 years they have to change that system to update these calculations. So then I'll put it as a quality requirement, maintainability in there. And now the architect, the development team, they can decide, estimating the effort to do that, shall we implement that already now? Or do we wait until 2 years when the things happen or not? So this is one important aspect, and of course all the functional requirements about data, functionality, behavior. So, and this can, I mean, there are different ways how to document functional requirements. It could be just a list of requirement statements. The system shall provide the user with the ability to do that and that. You could have a use case driven approach where you do a use case diagram. And for each of the use cases, you write a textual use case specification, which is in a way natural language requirements describing the typical scenarios through such a use case. So the interaction of the actors with the system. You might have models, analysis models. So the important here that these are analysis models, not design models in requirements engineering. So you could, for example, and you can have a mixed approach. So you could have some requirements are textual, but I still have a use case diagram, but I might not do specifications for all the use cases. For some of the use cases, I use activity diagrams to define the flow. In addition, I might have a domain model, a class diagram that visualizes all my domain entities. So that would be kind of data requirements, data structures, and the relationship of the data, and maybe state diagrams for some of these. So there are different ways how this can work out. So of course, if you have a source here, information, requirements, specification as input to you, and you open that and you see it's full of UML diagrams, you better start learning UML diagrams. So of course you need to see what is in there. If it's just natural language, it's easier. But if you are working in a process that heavily uses models to document also analysis requirements, you need to, of course, understand them. You cannot learn information that you cannot even read. Relevant information from user-centered approaches would be, as I mentioned, the user groups, or the personas. You remember the different kind of shoppers that I have in my potential set of customers. Scenarios and storyboards I mentioned already. So a scenario could be also just a textual description. And a scenario is something in UX where you actually describe an example. So it's not like a use case scenario, which is not a concrete instance of something that happens, but here scenarios are really where I describe a situation that happens, where maybe a user interacts with my product or with my system. And of course you can tell, I mean, this is ideal input for your test scenarios if you have these things. Or UI prototypes, wireframes. Sometimes a prototype can just be pen and paper. We will see that, we will do that tomorrow afternoon for the usability testing. You can just draw the UI on the paper and test that with the user. That works in many situations in the beginning perfectly fine. You don't need to use expensive tools and take days to draw that UI. Or you can just use wireframe tools like these ones here. It looks like it's kind of a sketch, it looks like it's hand-drawn. That's actually on purposely done. So this is also important in our project with Steam Turbines. In the beginning we were doing these UI mock-ups or UI wireframes using Visio, a horrible tool to do that. And they had some kind of a plugin where you could use all these UI gadgets. It looked like a screenshot of a Windows application. I mean, it looked perfect. I spent a lot of time always for each of these screens. The problem was that the users, when I showed that to the users and we discussed that, they thought that this is a screenshot and was implemented already. So they were not really, they were hesitant to tell me to change things because they knew that this would cost money and the project budget is tight. So this, of course, that was stupid from us to do that. So we switched, the next day we switched to that tool Balsamic Mockup. There are different other tools now available how to draw these. It's actually super easy to draw something like that. And now, after that, we would go to the user, sit together with them, and I could, when he tells me, okay, no, there's something missing here, a parameter should be put here, I would do it right away. So I would work together with the user in defining the UI together. So this is kind of the give you an understanding. So these are kind of potential sources of information that could help you in testing. So I'm not a tester, so please forgive me if some of the terms are not exactly correct as they're used in testing. So I used a little bit my feeling just to describe how can these different inputs from requirements engineering actually benefit you. So a vision, I mean, it's a management summary, so it might also be a nice summary for you. So a vision is something that can actually help you to get a basic understanding of the system. You might get new in the project. If it's a waterfall process, you might end up getting there. They didn't really tell you much about the project, so read the vision, get some high-level understanding. There's also risk already in there that might be interesting for you as a tester to see. Glossary. Again, a glossary can help you, again, to understand other documented information. I mean, when I came new in that steam turbine project, I needed a glossary in order to understand any other document that I was reading. Because there were so many technical terms in there that I always had to check back on the glossary. So this is something that can also help you in order to understand all these different requirements engineering input here that you get. Use the glossary if there is one, ask if there is a glossary to help you better understand, but also the glossary are the terms, the correct terms and the correct meanings as they should be used. So you should also use that in your test cases. So it has kind of it's twofold here how to use that, how you can benefit from that. System context. I mean, you get a very quick overview what external systems do I have for my integration tests or interface testing connections to other systems. But it also, and I see what actors do I have. So if it's for my scenarios, maybe it helps me also to better understand the use case. Maybe the context is a use case diagram already. So, and it also kind of gives a high-level view maybe of the features that I can use. Yeah, and then all these different functional requirement documentations help you to better understand what are requirements on functional behavioral data on the system to build all the different kinds of test cases. So I just dumped a lot of words about testing here on that list. So for all the different kinds of tests, depending on the process, how do I test? Is it automated? Is it automated acceptance testing? Can I use my activity diagrams to derive already test scenarios automatically out of that? So the details already depend a little bit how you work and what kind of information is available. So do I work agile? Do I have only user stories available? Is it like kind of a racial unified process that is all UML? So then you have like not only these 4 models, you have maybe 10 other models that you have to understand. So this is kind of the basic input you got. I mentioned before quality requirements. So the quality requirements are very important in order to understand these different aspects, these different quality aspects of the system. So what are the user looking for? And I mean, performance, usability, security, if these are killers. I mean, you can ruin a company by having a product that fails in these categories. If I click a button and something doesn't happen right away, or the page doesn't load sometimes, that's okay. But if all of a sudden I learn that my credit card information can be bought on a Russian website because I saved it in our web shop, nobody will use our web shop anymore. And you can see, I mean, it's crazy. Every week you read these, and they get more hilarious every time. Huh? I mean, there was the case when in the US, what was that company where they had all the credit check information? Yeah, Equifax, where there were social security numbers, addresses. So if I have that information, I can actually steal the identity of that person. I can get access to a lot of things, to their bank accounts, whatever, and they got stolen. The UK government lost social security records. I don't know, half of the adult UK people know about you. So, I mean, this you want to avoid. So that's why it's very important. Security, usability. If my product is not usable, people will not use our web shop. So that means we don't make money. Yeah? So these days, if it's customer facing, it's all about user experience. So that's why these are very important requirements. They're sometimes more important than some of the minor functionality things. So you have to test these things. So stress and load tests, performance tests, different system tests, create usability test plans. You will see that in a second, to do usability tests. Security testing, I mean, this was also mentioned in some of the other talks yesterday already. So if you don't know how to do that yet, I would suggest you start looking into that. Especially security is a topic that gets more and more cloud computing. I mean, now everything is on the cloud. I also was in a project where we have a system on the cloud now. And I must say, I sometimes really don't sleep well because of it's so easy to get access. And we are storing information that is actually business critical of our customers. These are business secrets that we store. If they get public, they can sue us and ruin us. I mean, and then you really think, wow, I really want to know if my system is secure. So how do I know that? By checking. So security is one of the big things in web application development these days. So, and it pays well. Huh? I try to look for a security expert to help me, maybe do an assessment. It's incredible what hourly rates they ask for. So if you are good in security, checking security, testing, setting up all these automated systems to check security, I think you can also do that only working 3 days a week for the same payment. It's not an easy topic. I mean, that's why not everyone is doing it. But if you're willing, invest some time. That's a good way to go. So I put some information there. Yeah, and if it's user groups, personas, they help you to better understand maybe the user stories, storyboards, because typically then the personas are also used in these stories or scenarios or storyboards. So you already understand better about the users, what are the motives, what are the behaviors of my users, to more critically think about what test scenarios you do. So Paul in his first talk mentioned, I mean, it's really about thinking. Don't just follow stupidly tests and execute them manually, think about it. And as we saw before, information, knowledge, thinking is about having knowledge. So the more information where you can acquire knowledge from can help you to better design test cases. You might find something in a persona that actually is not really in any scenario, and then you wonder, okay, why did nobody think about testing that kind of a behavior? Or I have persona storyboards, UI prototypes. Maybe I'm still more traditional process with function requirements. If you want to test usability, so all these information also helps you for the usability test plan. So it's not only the quality requirements, usability. And this is something that we do then, we will look at tomorrow afternoon if you're coming. So just as a high level view here. So what is a usability test? Usability test means I'm using some kind of a prototype that could be pen and paper, sketches, it could be some mock-up where I actually have something really on a phone. And I design a usability test script. So this is something where I ask the user to do certain tasks. I clearly formulate how I ask them these tasks. Of course, it is the whole setup. Then I give an introduction, I inform them what we are doing, I show them the system, and then I ask them, could you please, using that prototype of our web shop, and your task is it to shop the book Lord of the Rings and the DVD. Okay, and then the user would start and they would look at it. Maybe it's a clickable prototype already, or you help simulating behavior. And at the end, you might see that certain steps that you thought are easy are not easy. So there might be a moment where the user starts like, oh, okay, well, how do I check out now? And then you see the user kind of scans the screen, and maybe the user even says, I'm sorry, I don't know how to check out now. So you know test failed. Huh? Or it took too long. So in usability tests, you can also do quantitative measurements where you measure times and things like that. Or you can also use all these input storyboards, prototypes, if you need to design automated UI test scripts. So you already have that, you can already plan ahead and maybe use some of the technology. So tomorrow in the other tutorial where we do the behavior-driven Cucumber. So I will also talk a little bit how to use Cucumber to do automated UI testing, for example. Okay, yeah, still time. So now I just wanted to give you a brief overview. What information do we have? So now you have to study. You have all that information. You know why you need it. But now I have to bring all that information and create knowledge in my head. So I sit down, I read the vision, have my glossary ready, and then I dive into the requirement specification, maybe the models. And you will realize that some of these artifacts, these documents, are actually quite suitable to acquire knowledge from it. But because they were actually created to be studied by somebody else. But others, I mean, if I would just give you the backlog with the 200 user stories from my last project, it wouldn't really help you much. You just have these statements, as a customer, I want to do this so that. If I give you a storyboard, that's nice pictures, maybe it's funny, entertaining cartoon, but also there's something missing here. Also just the UI prototype alone So a lot of information you will realize is actually not really so well suited to acquire knowledge from. Why is that? Because some of the information is actually just an aid to remember. I used here the term knowledge anchor. So what does it mean, knowledge anchor or memory aid, or how you call that? Or you can also see that as a little bit like an externalization of my brain. So because I can't keep everything in here, I put something here. So what does it mean? So let's imagine I know something. I have some knowledge about something, but it's a little complicated knowledge, so I sometimes have tough time to remembering, so I just write down some notes about it, maybe a little guideline for myself, or I do a sketch, images. I mean, some people remember well if they draw like an infographic. So if a month later I actually need to activate that knowledge, I just take that little note or sketch, and if I look at it, I sometimes don't even have to study it really. It's just enough to see that image, and bam, the information comes back, the knowledge comes back. So this is a kind of knowledge anchor or memory aid. So I do in a way an association in my mind with that note, image, so it helps me to remember. You might all know, I mean, sometimes you hear a song somewhere in a shopping mall, and bam, you're back 10 years ago, where you maybe were dancing with somebody nice to that same song. So there are a lot of these anchors that kind of are built into our memory that can help us to actually quite easily remember a lot of things, because nothing gets lost in here so easily, but you have to access it. So the way to access it is the problem. And these knowledge anchors, and anything can be a knowledge anchor, could be that little duck there, and if I see it, I might remember the good times I had in a warm bubble bath. But it only works if this is my duck. Yeah? If you look at that duck, you wonder why does Matthias has that yellow duck on his desk? It's not a knowledge anchor for you. Huh? So, and in the same way, you could say a user story, if it's just like that note written on the board. If somebody comes or you as a tester come in, or some manager, and they have not been involved, and they look at that board and they see these little funny yellow notes, it doesn't really tell them something. But if it's the requirements engineer or the team who worked on that, for them it's clear. I sometimes just need to quickly browse through the backlog, and I remember the things. So what do I actually remember is just looking at that user story brings back all the discussions I had with the users, or all the discussions in the team when we were planning the user story. We were kind of going through all the tasks that needs to be done. Maybe we had a workshop about it. So just looking at that little user story brings all that back. And actually in Agile, I mean, a user story is not, the purpose of a user story is not to document the requirement. That's why it is done to kind of foster communication. It's actually something where people should start talking about, and by talking about it, discussing about it, you learn, you generate knowledge. And then this little piece of paper on the wall is again then just the knowledge anchor for all these people who were part of that discussion. But that's the problem. If you were not part of that discussion, you were not in the project, and they bring you in and say, okay, now test all of that, here's the backlog, please go. Yeah, that's the problem now, no? Because you don't have all these knowledge learned about it. And some of these information is not so suitable to do that. Ooh, yeah, let me speed up a quick little. So what you need to do is, in a way, in this case, you need to find the person, the authors. So if the requirements engineer is there, they have to explain you the backlog. Go through, and you have to kind of quickly repeat that process of learning. Is it always possible? I mean, in the ideal world, in an agile project, you are part of the team. So you are here, sitting there. You are always there, from the beginning on. So you will have that knowledge about the product backlog in your head. So you have all the discussions, everything, you were part of that. So there's no problem. Huh? It's part of the process of Agile is that you are there. Let me skip that. Unfortunately, sometimes you're maybe not even in the same country. You might still be considered part of the project, but then maybe a day before the sprints and they call you and say, okay, now please test that. Yeah, that gets difficult. Huh? And the further away that gets, worst case is you don't have access at all. And this would be in a way the case of a waterfall. I mean, that's how waterfall is designed. But it would not work for an agile or user-centered approach. So if you now studied all the information, you gathered it, you know it, you have all that in your head, all the learning, all the knowledge, maybe even some discussions with people about it. So now that helps you to better design your tests, better execute the tests, create automated tests of that, and become a better tester. So deriving intelligence from requirements engineering for better testing, in Agile it's part of the process. It comes with it for free. In waterfall or more structured processes, it requires time and effort from you to gather the information, study it, apply it. And as a message, I think it's also important as a tester to know more about requirements engineering. So in order to better understand also these artifacts and better question requirements, so you understand how were they done, you're able to question the things, and that's also important, like Paul said, not just take everything for granted that was done here. So maybe do a CPRE foundation level certificate, even as if you are a tester then. Huh? Yeah, thank you very much. Just 1 minute over time.